Okay, now we got this problem. Tugboats pushing on a barge. I don't know what's on that barge. Oh, and there's stupid numbers. Why did they do that? I'm just going to immediately rewrite it. 2.7 with 1, 2, 3, 4, 5 zeros. Well, not really 5 zeros. There you go. 270,000 newtons, and then 3.1, 2, 3, 4, 5. There. Because I get confused. So there we go. And then, let's see. One tugboat, blah, 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 blah. The mass of the barge is 5 with 1, 2, 3, 4, 5, 6 zeros. And acceleration is tiny. Okay, so the acceleration is 0.075 meters per second squared. Okay, now everything is back where it's supposed to be, and I'm not scared anymore. Okay, what is the drag force of the water on the barge resisting the motion? Okay, so let's see what's going on here. So I've got a boat, and for the purposes of this class, this boat is a dot. Because it doesn't give me dimensions of the boat, therefore the boat is a dot. Okay, so I know that there's a force here. I'm just going to redraw it, because when you redraw it, you make it your own. So there's 270,000 newtons by that dude. And then there's 360,000 newtons by that dude. Notice I'm not drawing the acceleration on this because that's not a force. Okay, and then there's a drag on the motion. So that means it's preventing the motion. So I might be like, okay, so the motion is this way. I always use my special color, so I know that this is not a force. There's a acceleration in that direction. So that must mean there's a drag in the opposite direction. It's like friction. That's like the frictional force of the water. So there's the drag there, and it's at 53 degrees. 53 degrees, and then there's the drag. Okay. Now, does it matter? I think the book, yeah. So your book actually draws the drag on this side. It doesn't matter if you draw it on this side or this side. I just drew it up because that makes more sense to me. Like it's pushing, not pulling. But I mean, it from a physics perspective, it doesn't matter. Okay. So in theory, that's mostly done. We just need to break it into pieces. So come here, piece of paper. Merps, merps. Okay. So I'm going to break this dude up into, we'll make this a little bit longer just so it's easier. We'll break this dude up into ponk and ponk. So the opposite is sine, so d sine 53, and d adjacent is d cosine 53. So if I look at this sum of the forces in the x direction is 270,000 minus d cosine 53 equals mass times acceleration in the x. And I don't feel like emotionally handling that yet, so I'm just going to leave it. But I know it's not zero. Then the sum of the forces in the y are 360, tomp, up, minus d sine 53 down, and that's equal to mass times acceleration in the y direction. Again, I don't want to pay attention to that yet. Okay, so what's the mass of the barge? Oh, I already deleted it. It said the mass of the barge was, oh, it's that 5 million thing. Okay, so the mass of the barge is 5 million. So 5 million. And then we need to know the acceleration in the x and y. Well, we know the acceleration is 0.075, hopefully. So 0.075 meters per second squared at 53. So the two components of acceleration would be, like if this is acceleration, the two components of acceleration are, now notice the direction I've drawn acceleration because it's accelerating, it's not decelerating. So 0.075, opposite is sine, and adjacent is cosine. I'm just going to go ahead and get those as real numbers because I'm getting to have too many weird things going on. Times sine 53. So that's 0.06, basically. I'll use the real number in my actual calculation. And then the same thing, but with a cosine. 0.045. So in the x direction, this is where I would get it wrong. I would put the 0.6 and the 0.45 in the wrong places. But also they're positive. So this one here is, I'm going to switch out of this weird pen. Just go to green. Okay, so A in the y direction is 0.06 in the positive direction. And A in the x direction is 0.045. So it looks like I don't even need both of these equations because there's still only one unknown. But I'm going to solve it twice and just make sure I get the same answer both times. Okay. Okay. So let's see, what do I got here? So I've got 5 times 0.045 minus 270,000 is, negative 44,319. So negative d cosine 53 is negative 44,319. Chunk, chunk. Thank you. And then I'm going to divide by 53 degrees, or cosine 53. And I got 73,642. That seems like a lot. Let me do it the other way. 642 newtons. And I'll probably get the same answer. It just feels like a lot. Okay, let me do the other one. So I should get the same answer both times. So 5 times that 0.6 minus 360,000. Oh, minus, not times. That would be a big deal. And then divided by sine of 53. But I need a negative on it. Oof, I got a different answer. 450394. Okay, so I did something wrong. Let's figure out what it was. Whoa. I did not multiply by the right number up here. That's what happened. That's in no way 55 million. 5 million times 0.06. Let's try that again. .06 minus 36d 123. Okay, that was a totally different number last time. Divided by negative sine of 53 degrees. Thank you. Escape punk. Thank you. There we go. 7,568. Okay, well, something's not quite right, but I can figure that out. 7,568. I wonder if that's just a 7,568, 7,5,7,6,8. Okay, I'm going to look at my math one more time and make sure I didn't do something silly. Okay, I think I figured out what's going on. The book is solving this problem a different way, and they picked the numbers on purpose to like basically even out to something. And then when you solve it correctly, it's not physically feasible. That's fine, you know. they're doing their thing, we're doing our thing. For the purposes of, pedagogy, these are good enough. We're going to say good enough for government work. You have to expect losses in bigger operations. This was a bad problem because they did something really weird and I don't like the way they did it, and it's not a long-term solution to learning stuff. So I would not do it that way. I would do it this way, but just know that in real life, this would have to be done better. I guess the drag would have to be in a slightly different direction. So I guess that's fun.